Let's find the LU decomposition of a 2 by 3 matrix. So it's 1, negative 2, 3, 4, negative 5, and 6. So we want to find LU decomposition. We'll call this matrix A. So find L times U to equal A. So good thing to note is, well, first A is a 2 by 3 matrix, and U is always going to be the same size as A. So at this point, we need to figure out what L is going to be. L is always going to be a square matrix, and for this, we know it has to have 2 columns because these two numbers have to be equal. And because it's a square matrix, this has to be 2. So the number of rows and columns are the same. And also, whenever you're multiplying matrices, it's the rows of the first one by the rows of the second one. So that's what we have over here. So L is going to be a 2 by 2 matrix. So we'll say 1 on the diagonal, then 0 above it. So we just need to figure out what goes in this second entry. So the way to do that is to start off with your matrix A rather. And the goal here is to have upwards, numbers on upwards, and then on the bottom have 0. So another way of saying this is if everything below the diagonal should be 0. And so there's only one number. So let's make 4 0. Okay, that's the goal. The way you do this is multiplying negative 4 times the first row with the second row, and that's going to be my new second row. So we'll call this U. And this, the first row you just leave the same. The second row we have negative 4 times 1 plus 4 is 0. Negative 4 times negative 2 is 8. Plus negative 5 is 3. Negative 4 times 3 is negative 12. Plus 6 is negative 6. And so this is good now. We found U for for L. We just take the opposite sign of what we multiplied the first row with. So we multiplied it by negative 4. Take the opposite of that. That's going to be 4. So my L matrix is 1, 0, 4, 1. And U matrix is 1, negative 2, 3, 0, 3, and negative 6. And that is our answer.